but talking about inverses. All right, so we're going to start with some basic stuff here. This is number 6a, the inverse sign or the arc sine of 0. So again, where is the y value 0 on your unit circle? Where is y 0? Remember, inverse sine only goes from 0 to pi over 2 and 0 to negative pi over 2. So where is, and so is inverse tangent. Where's y 0?
0 pi.
Yeah, 0 pi. So that's right there. Okay, 0 would be the answer. All right. Then 6b, the arc cosine of negative 1. So you got your memory going yet? Where's the x value? Negative 1. And remember again, the arc cosine goes from 0 to pi. So where is, yeah, at pi. Good. We all good? One more? No? Okay. All right, let's keep going then. That's pretty much what you're going to be saying the whole day. So let's keep going, get it done quickly. Okay, now grab your calculators. Make sure you are in radian mode. It actually tells you use a calculator to find an approximate value in radians of each expression rounded to the 5 decimal places. So number 10. Number 10 is the arc cosine of negative 0.2. Okay? So you put that in your calculator and tell me what you get. Harpreet, what'd you get? 1.77215. All right? Yeah. Okay. Awesome. Awesome. All right, so visually, what are we looking at here? When x is negative, we're in the second quadrant for arc cosine. We're not in the third quadrant, okay? And it's negative 0.2, all right? So if this is negative 1, negative 0.2 is about right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0.2 is right here. So if you drew your unit circle, okay, then the radian measurement is this piece right here. Okay, so 1.77. All right. You don't need the visual. I'm just telling you that stuff, okay? So that's how you use your calculator, but make sure you're in radian mode when you're asking for the radian measurement. Remember, 90 degrees is 1.57 or 1 point something, I don't know. All right, so let's go on to, I think you can use your calculators, can't you? All right, so go ahead and put them back into degree mode because we're going to find degrees. Did you understand what I said about this? The radian part? Yeah. This part right here is 1.77 from the coterminal. Okay, just making sure you understood what I was saying. All right. What? You didn't? Hold on a second. Let's bring it back down.
I got it.
The distance, oh, you got it now?
Yeah, I got it.
All right. Does everybody understand what we're doing when you're doing the radian measurement from the coterminal to that position? Okay. Okay, that would be kind of like a reference radian measurement. Okay. All right, so now we're going to draw a triangle here. Wish I could easily draw triangles on this. Let's do number 18. And here's your triangle. So your right angle is up there. This is 7, this is 18, and this is our theta. And this is straight out of your freshman year algebra class. Find the angle. Round to 1 decimal place. Okay. What have we been given? Opposite leg and the adjacent leg. Those are legs. Don't say your hypotenuse is a leg. A hypotenuse is not a leg. Okay? So that is the opposite leg and the adjacent leg. Which trig function are you going to use to solve this? Tangent. So we quickly grab our calculator, and we have the tangent of theta equal to 7 over 18.
How do you know if it's tangent?
Opposite over adjacent. So Katoa, here you go. Watch. So Katoa. So opposite and adjacent is the tangent. Okay? And those two legs, these are legs. Attached to 90 degrees is your legs. Are your legs, okay? And this is always your hypotenuse. So this is the corner we're talking about. So what have we been given? Opposite and adjacent. So sine and cosine all use hypotenuses. All right? So how do we solve this? We need to get tangent to the other side so we know what theta is. To do that, we take the inverse of 7/18. So grab your calculator, make sure you're in degree mode, and tell me what the arctangent of 7/18 is. Round to the first decimal place, please. Yep, 21.3 degrees. I'm not sure why that did that. 21.3 degrees. Who needs help? You need to make sure everybody's getting these. We good? Anybody not understand what's going on? Do you want to see another example, or can you find your angles? You need to say so now. You want to see another one or not? All right, moving on. Good job, guys. All right. So the next set of examples is basic trigonometric equations. And this is where students are struggling a little bit, but once you see it, I think you can do it. Your answers, I want your degree. You're going to find the degree, but I want it between 0 and 180 degrees. So here's what we're talking about. I'm going to do number 28 to explain why there's possibly more than one angle. So if I say the sine of theta is equal to 4/5, I want to know the degree. All right, so sine represents the y value. Y cannot be bigger than 1. Cosine cannot be bigger than 1. Tangent can be bigger than 1, right? Okay, so remember that because it's possible you have undefined stuff. All right, so here we are. The y value is 4/5. This is the visual behind this. If on the unit circle, this is 0, 1, right? 4/5, 1, 2, 3, 4, 5. 4/5 is right here. So on the unit circle, you have two possibilities where the y value is 4/5. That's visually what you're looking at here. So I want to know that angle, and I want to know that angle. That's why there's two possibilities. It's easy for you guys to find the angles. How do you find the angle? By taking the arc sine of 4/5. Everybody do that to get the first one.
Will this be in degrees or?
Are you finding degrees? Then it should be in degrees. That's how you tell the difference. It's your first lesson where you have radians and degrees in the first in the lesson. Same lesson. 53.1 degrees. That's this one right here. Now, how do I find the other one? This right here is also 53.1. So how would I find that degree? 180 minus the 53.1, right? So what is that? 126.9. So you have two possible answers for the sine. Okay? let's do, let's do 24. 24 is cosine of theta is 3/4. Again, I'll draw a visual part up here for you. Cosine is 1 there. We're in fourths, so 1, 2, 3, 4. 3/4 is here. Positive, cosine is positive in the first and the fourth quadrants. So first, find the first angle. So visually, that's what you have, 41.4 degrees. How do I find that angle? Yeah, 360 minus the 4. This is also 41.4 degrees right here. Say negative. So 360 minus that. Very good, 318.6. Who got it right? Everybody, yeah, you guys are so brilliant. Do you feel smart? No? All right, well, I failed. You guys should feel smart because the fact that you're bored with this shows that you worked hard in January. This is all unit circle stuff that came from this, okay? So let's do something a little more difficult then. Now, put your calculator down for a second because this says exact value. Exact value means don't touch your calculator. So I want the exact value of this expression. Here we go, number 30. Let's hear everybody moan at the same time. The arctangent 4/3, and what's the cosine? All right, this is really pretty simple. You probably don't remember how to do this because 4/3 is not a unit circle value. So we're going to have to figure these out. Here's how we do this. Where is the tangent positive? First and third quadrant. So if I were to find the arctangent 4/3, what would I get in the first quadrant? Arctangent 4/3, please. On your calculator. I told you to put it away, but for right now, I just want to know, for a visual purpose, where we're at. Sorry. 53.1. All right, so visually, I'm right there, right? So this is what I want you to do. Figure out what quadrant you're in. Draw a right triangle. Tangent represents y over x, doesn't it? So my y is 4. My x is 3. What is my hypotenuse? Everybody should know this is a 3, 4, 5 right triangle. Okay? All right, now, what's the cosine then? Cosine represents adjacent over hypotenuse. So what is it? Yeah, 3/5. That's my answer. That's the exact value. Okay, I just wanted to show you that this is actually correct. If you took your calculator and you said that this was 50 what? 53.1 degrees. Okay, take the cosine of 53.1 degrees. Now make sure you're in degree mode. Cosine of 53.1 degrees. You should get 0.6. Isn't that what 3/5 is? Okay. Okay. Is it exactly on your calculator or is it rounded?
It's 0.60.
Yeah. The point is, you've been taught how to find exact values. Your calculator can only get close. Okay? A 3, 4, 5. Oh, Pythagorean Theorem. So a squared plus b squared equals the c squared. 9 plus 16 is equal to c squared. So c is 5.
Oh, you just took 3 and 4.
Yeah. So it's a typical triple, 3, 4, 5. That's all right. Most students. Oh no, what's going on here? There we go. Sometimes it'll only move one screen on top of the other screen, so I don't want to do that. All right, here we go. Next one. So you got to be able to draw right triangles to get this stuff done, guys. All right, last set of instructions here. Rewrite the expression as an algebraic expression in X. This is difficult. You're not going to know how to do this unless you pay attention. Again, you're going to draw a triangle. So this is number 36. This is the sine of the arctangent of X. So we're going to write this as an expression of just X. You do the exact same thing that we just got done doing. Again, the tangent is positive. We're going to be in the first quadrant. So I'm just going to draw a generic triangle. Tangent is y over x. And what we have here is x over 1. So I'm going to put these in the correct positions. All right, so pay attention real quickly. Y is x and x is 1. Those positions. So x goes in the y position on your opposite leg, and 1 is your adjacent leg. Now, you need to use the Pythagorean theorem to get the hypotenuse because we're finding the sine of whatever this triangle is, which you need the hypotenuse to do that. Okay? So, Pythagorean theorem again. 1 squared plus x squared equals my hypotenuse, right? Squared. All right, so really this is just x squared plus 1 on the left. But remember, you need to take the square root of both sides. So h is the square root of x squared plus 1. All it is an expression, and you're just putting in them in the positions. So let's go back over this. Yeah.
So, if x equals 1 and y equals x,
No. No, don't, no. I was just showing, let me rewrite this then. I confused you. Okay. This is the opposite leg over the adjacent leg. Let's not use x and y. Okay? Because it can get confusing. And it did. Okay? So now that we know what the hypotenuse is, the sine of theta is the opposite leg over the hypotenuse. Opposite leg is x. This is theta over here. And the hypotenuse is the square root of x squared plus 1. Why won't it let me do that? Erase it. There we go. Hit the wrong thing. Okay. The book leaves it like this. This is not correct. We should not leave it like this. I mean, we've been practicing all along not to have radicals in our denominator, and all of a sudden the book says, oh, let's just leave it like this. Okay, so when you're doing these problems, you need to take it one step further for the test and the quiz I give you. But in the book, it's going to stop here. So what do? That's right, you got to rationalize this. Don't worry, you're done. Now you're done, okay? That didn't hurt you, did it? To do that extra little step. Okay, so what is it that you do on these types of problems? Draw a triangle. you need to identify which quadrant you're in. So that when you take square roots and stuff, you know which legs are positive and which ones are negative. Okay? And that's it. We could do a story problem, but I think I'll just wait until you come into Tuesday and say, I don't know how to do that. And we'll go over it. All right.